Hello, this is Nazeer from the Faculty of Civil Engineering Technology. Welcome to all of you in Canada and around the world. These videos are made for my students in particular because we are under lockdown because of the coronavirus. This is about March 22nd, so I'm making some videos hopefully to help with the schoolwork that has been assigned. Keep in mind that not all sections will have videos because these are fairly difficult thing to produce. When we look at what we have on the screen, we have an ellipse. An ellipse, you could call it an egg-shaped type of shape, but the major thing that we have to look at is has a major axis right down the middle, and it has a minor axis right in here. So when we look at the ellipse, I'm just going to switch to laser here. We have a major axis right there, and what we call a minor axis or a co-vertices on the perpendicular of that major axis. When we look at the equation for an ellipse, it is x squared plus y squared divided by a squared or b squared there, and we'll see that as we go through, and a squared plus b squared equal to 1. Okay, so this is the equation. Again, I'll just repeat it. X squared divided by a squared or b squared, y squared divided by a squared or b squared, and we will see why that or a and b comes into play. When we look at this, the a squared, the value for a squared is the one half of the major axis. We'll discuss that later. When we look at this notation that I have here, a and a prime are the same length, so we'll get into that also in more detail. When we continue with this, we see that we have the major axis, which is the longer of the two axes, right? And then when we look at the distance from the center to the vertex of the major axis, it is a, right? It's a distance. So therefore we have 2a for the full major axis. When we look at the minor axis or co-vertices right in here, we see that it makes a perpendicular with the major axis, and of course these are vertices in the opposite direction of the major axis. Again, from the distance from the center to that particular co-vertex, it is called b, so then therefore 2b will be the whole length of the minor axis. Okay, and usually with not usually, all the time with ellipses, you have what we call focal point on the inside, two of them. You could look at it as basically two parabola, which is not a true statement, but two parabola cut in half. You'll have two parabolas with their focuses on the inside along the major axis. The next step that we have here that I want to explain is that the length from the center to the vertex of the major axis, that particular length is known as a. 2a is the full length of the major axis. But when we look at the minor axis, the unique thing about this minor axis, it makes a 90 degree with the major axis, which if we were to join the co-vertex to the focus, we would have a right triangle. Therefore, we have Pythagoras theorem and cosine and tangent that would be applicable. We'll just use Pythagorean theorem to solve for this value of c. The important point, if you don't have this piece of information, a, the length of a, and the length of a prime is the same. It is the phenomenon of an ellipse, right? It just happens to be that way. It's it's just a phenomenon of this particular shape. The distance from the co-vertex to the focus is the same distance as a, which is one half of the major axis. Okay, so I hope that this is important stuff to understand to solve ellipse type of equation. And again, ellipse type of equation, you will have x squared divided by a squared, y squared divided by b squared plus these could switch around the denominator depending on whether it's the major axis or so. In this case, we have a major axis that's happening here, so the larger of the numbers will go on the x, right? So the orientation from the time that you examine these, and the orientation will be dependent on what the values are. If this happens to be 25, this happens to be 16, then you have a major axis that is larger on the x-axis, so it's a horizontal. It's a horizontal major axis. Let's go to the next slide. The vertices x and y is a coordinate point on the ellipse. The vertices A and B are distance from the center to the major axis and the co-vertices respectively. When we look at the equation given here again, we have x squared divided by a squared plus y squared divided by b squared is equal to 1. Just by examination, because a happens to be on the x, this is a horizontal major axis, right? And when we look down here, we see that the larger number happens under the y, and of course that means that the major axis is along the y-axis in this case, right? The other thing that I've written here is that A represent 1/2 of the major axis, right? Just 1/2. 2A would represent the full major axis. As we look at this, A and B vertices define the major and minor axis. These two, major and minor axis. The larger the number is A, which is the major axis. So again, examining these numbers, the denominators, you will pick out which one is the larger number and know, depending on whether A happens to be on the y or it happens to be on the x, that's where your major axis goes. This one is a horizontal major axis. This one, because the switch around of the A and the B squared, it is a vertical major axis. Okay? I hope that you notice the difference between the two equations. Again, when we look at the parts of the ellipse, we have the center, we have the co-vertex and the vertex, which along the major axis and along the minor axis. We have the two focus points, right? These two focus or foci, they are inside along the major axis, inside of the ellipse along the major axis, and the distance from here to there is considered to be C. The distance from the vertex to the center is considered to be A. The distance from the center to the co-vertex is considered to be B. We know that these are 1/2 of the major and minor axis, major axis being A, minor axis being B. Want to bring about your attention to this, what I have here. This is a coordinate point on the ellipse, anywhere on the ellipse. And of course, these x and y there, if you wanted to find one of these guys, or you could plug in that coordinate points in those positions and then continue to solve. I think that's all for this particular slide. Let's go to the next one. Because we know that from the co-vertex to the focus is the same distance as A, and we have a perpendicular right there, we will call that hypotenuse A prime, right? A prime is the hypotenuse. We could use Pythagorean theorem, and of course because the hypotenuse is there, we're going to put the hypotenuse minus B will give you C. Again, the hypotenuse minus hypotenuse squared minus B squared will give you C squared, right? So that's just what is there. And again, if you take the root of both sides, you can end up with this. I would suggest that you actually memorize this formula if you want the distance from the center to the focus, root of a squared minus b squared. When we look at the equation again, we are looking at this is where the center is not at the vertex. The center is not at the vertex. And of course, h and k represents the coordinate for the center, right? The center, the coordinate for the center. And x and y represent a point on the ellipse. And this is being explained here. Coordinate of the center. And this is the point on the ellipse. Right, so we have to keep those things in mind also. Just a reminder that there is a YouTube video on the ellipse itself, not solving problems, which we are going to solve problems in this particular video. Write the equation of an ellipse whose vertices are minus 5 and 0, plus 5 and 0. Because we have 0 in the coordinate set, the ordinate is 0. That means that this is going across, it's symmetrical to the x-axis. It's symmetrical to the x-axis. It's symmetrical. You have minus 5 and 0, and then you have plus 5 and 0. So that means that the center is going to be at the origin. The center of this ellipse is going to be at the origin, because if I have the major vertices 5, minus 5 and plus 5, that is the center is at the origin, and whose co-vertices are 0 and minus 3. So if I go 0, this is on the y-axis, and minus 3, and 0 and plus 3. Find the focus and the ellipse. One of the things that I have to basically point out, when you're given coordinate set, just start plotting them up. You know, it makes sense. You have a visual, and it becomes fairly clear, right? So find the focus of the ellipse. So we have to go and use that equation that I just mentioned that we would memorize. C is equal to the root of a squared minus b squared. So let's go and plot these things up. So when I plot these points up, this and this, the center is at the origin, and then we're going to go and plot up these points, plus 3 and minus 3. Okay, so let's go and look at this. We have our equation. We know that either A or B, we have to place them. Because this is the major axis, I could see that it's longer. I am going to put A along the horizontal. A square will remain here, B square will go, and then B square will remain here, A square will go. So the next step of this is to just write the equation of the ellipse, right? And it is right there. We could go and fill in the numbers now. For A will be 25 and B would be 9. I wrote it as 5 squares so that you could understand, but you could just go and put in 25 and 9 in their respective positions. And of course, we are asked to find the foci. So we know that we have to use that formula, Pythagorean theorem. And of course, when I do that, C is equal to A, which is 5 squared, which is 25, minus B squared, which is 9, which will give you 9 minus 25 will give you 16. Root of 16 is plus or minus 4. So when we go and just draw this up, and we'll see that basically it's the same as that. The major vertices, the co-vertices are in place, and now we have right in here we have the focuses, or the foci of this. It's the plural form, or focus, right? So, and that's how easy this is. But without actually knowing the parts of the ellipse, you would not be able to do this. You don't know what A and B is, you don't know what C is, you don't know that you have to use Pythagorean theorem to solve for C, and so on. So there's a lot here that we need to look at. Let's go to another one. Find the coordinate of the vertices and the foci of the ellipse. We are actually given the equation of the ellipse this time, and we know that the denominator here could be written as 10 squared and 8 squared, right? But we are asked to find the vertices. The vertices are very, very easy. Just analyzing this particular equation, I could see that I have plus or minus 10. Because I don't have any other numbers up here in the numerator, I know that this equation, the center of the ellipse, is at the origin. The center is at the origin. We know that will be plus or minus 10 and plus or minus 8 is going to be our numbers. The major axis is along the x-axis, which makes it a horizontal ellipse. Right? So when we look at this, we're looking at this equation right here. You know, plus or minus 10, plus or minus 8, and we have our center at the origin. The center of the ellipse is at the origin. The major axis is parallel to the x-axis, and the c value, the distance from the center to the focus, is plus or minus 6. Right? How do we get that? A squared minus b squared will give you root of 36, which is plus or minus 6. So we have all of the parts that we need to actually go and plot this up, and let's see if I've done the plot for it. Yes, I have. We have, like I mentioned, plus or minus 10 along the x-axis, which is the major axis, and the vertices are located there. The minor vertices now, plus or minus 8. So we have plus 0, 8 and 0, minus 8. Those are the vertices of these particular points. But we still have to find the foci. When we look at that, we have the information to plot it up right there. And of course we go and place them along the major axis. Alright, so this is this again not very hard once you know the parts of this. When we look at this, find the coordinate of the vertex and the foci and plot the ellipse. So when we look at this is a little bit different again. Right? Because there's no x term up here and no y term to the first power, we know that this center is at the origin, but this doesn't match the form that we want. The 9 has to go. And I'm going to use in here equivalent fractions, meaning that if you multiply or divide the numerator and denominator, it keeps the same value, but the way it looks changes. So I'm going to divide this particular term, and terms are separated by minus and plus signs, this particular term by 9. If I divide the numerator by 9, it becomes y squared, and this becomes 25 divided by 9. And that is exactly what I did here, right? We understand that the 1 is there. It cannot be 0. Cannot be 0 because division by 0 is undefined. So therefore it is a 1 that's there. I just put it in this form so that we see the pattern of the standard equation that we use in this case. The center of the ellipse is at the origin. We know that. The major axis is parallel to the y-axis. Why is that? Because this is greater than 1. This is the larger number of the denominators here. This is 1. If 9 2 is 18, it wouldn't go 3. But 9 2, at least I know that this is larger. So that's why the major axis is along the y-axis. Right? So the other thing is I'm going to use Pythagorean theorem to solve for c, which is the distance from the center to the focus, right? It's distance from the center to the focus. And then I would come up with my a value plus or minus 5 divided by 3. My b value happens to be plus or minus 1, and my c value happens to be plus or minus 4/3. right? Because we went and did this calculation here. 9 from 25 will give you 16, and of course you have these numbers that we are dealing with. So we are looking at 16 over 9. We take the root of both of them. You can have 4 divided by 3 plus or minus, because it's on either side of the origin. And let's go and plot that up. We know that our A value right there is along the major axis. So it is plus 5/3 and minus 5/3. Alright, so it's the ordinate of this particular set. When we look at the minor axis, which happens to be the along the x, we have plus 1 and minus 1. And then we need to go and plot our foci. Our foci were plus or minus 4/3. I know it's along the major axis, and of course I plot that in there. And I believe that's all there is for this one now, so not very much here. When we look at this particular problem, find the coordinate of the vertices and the foci of the ellipse, and you're given the equation. But it is not in standard form, it's more or less in general form, right? And we know our equation for an ellipse. It tells us it is an ellipse. We know our equation for the ellipse, and of course we are going to use that. We know that x squared divided by a or b squared, y squared divided by a or b squared is equal to 1, and you have a plus in between those two terms. Now, for us to actually take this and make it adhere to this particular form, we need to get rid of the 2, 3, and 6. We need to somehow bring them in the denominator and make this into 1. So the easiest thing to do this is I'm going to divide everything by 600. If I do that, then this becomes 1, and then I'll work from there. So that's what I've decided to do here. Divide by 600, divide 600 by 600 to get 1. Anything divided by itself is 1, right? And then 2 into 600 will give you 300, 3 into 600 will give you 200. So now we have it in the standard form of the equation for an ellipse. Good. Let's go to the next step now. We are going to pick out our A, B, and calculate our C. So when we look at this, we are looking at, I'm writing this as the root of this squared, because I want it squared, which is really 300. I mean, if I take the root of 300 and square, you could see that that cancels out. It's really just 300, but I wrote it like this to show that this is the proper form. You have to write the denominators of each one of these terms as the square. So I'm taking the square root of 300 and squaring it. It's in form. It doesn't change the value very much. And the same thing happened with this particular term here under the y. I'm going to go and calculate C, which is the distance from the center to the foci. I'm going to take a squared right there, put it in there, minus b squared right there, take the root of that. So if I subtract these two, I get 100, take the root of that plus or minus 10. So I have all the information that I need to plot this up. Let's go do that. Just a sort of summary of what we have done already. The center of the ellipse is at the origin, we know that. The major axis is parallel to the x-axis. How do we know that the major axis is parallel to the x-axis? Is because of the value of a, right? When we look at these two, we see that this is 300, which could be written as 10 root of 3, and this could be written as 10 root of 2, right? So we see that the larger of the number is on the x, so then the major axis is parallel to the x-axis, or on top of the x-axis in the math speaking. And then we would go and plot this up. We know that our major axis is right there. I'm writing it as 10 root of 3, so plus or minus 10 root of 3. That would be along the major axis right there. And for this one, plus or minus 10 root of 2, which would be the minor axis right there. And then I went and solved for the foci, plus or minus 10. So when we go and put those in, we have plus 10 and 0, minus 10 and 0. And again, you're finished with that. Let's go to this particular equation. Find the equation of the foci and the ellipse of the ellipse given the minor axis. The length of the minor axis is this. So if we were to think of this as the length of the minor axis, that is the whole length, so from the center to the co-vertex, it will be half of that, which is 4. And of course, when we look at the vertex, they give you one of the points on the vertex, and then they tell you that the center of the ellipse is at the origin by this. Let's go and plot the coordinates. Right, so if I were to look at the equation, it would be something like this. I've already decided that along my y, and maybe it'll be clearer if I were to plot this thing instead. So let's go and plot these points, and we have along the major vertices. It's because of this being the ordinate, it's plotted on the y-axis. So plus or minus 5. It tells you that it's minus 5, but because this says that the center is right there, then it has to be plus or minus 5 for the major vertices. And then when we look at the second part here, we know that plus or minus 4 from the vertex, because it's the total length of this. We know that the major axis and the minor axis, there's a perpendicular right there. And of course, we're going to go plus or minus 4. And that's what we have, plus 4, minus 4, and 0. Inside of this parabola, of course, there is the foci. And we've calculated, seeing that we have A and B, we could just use the equation. C is equal to A squared, which is right there, minus B squared, which is right there. And when you 16 from 25 will give you 9. Take the root of that, plus or minus 3. So when we look at the y-axis, and the foci are along the major axis, when we look at the y-axis, we have plus 3, 0 and plus 3, and 0 and minus 3. And again, that is all there is for that one. I think my computer is running a little bit slow, but nevertheless, let's look at this. Solve for y. Solve for y. Of course, we're given the standard form of the equation. I want to point out to you this time that we're asked to solve for y. We have to decide which is y. And of course, the other thing that I want to point out on this particular is that we have a minus 7 in brackets. It's a binomial in the numerator squared. That means that this center is not at the origin. That means that the center of this ellipse is not at the origin. We could go and put this in standard form, and or in general form, get rid of the denominator, get rid of the denominator by multiplying each one of these terms by 49 times 36, because they'll cancel it out, and that's what I've done to each one of the 3 terms. Right? You can't forget that that applies to the 1 also. So I am multiplying these letters in black will cancel out, and you have 36 times that binomial. And of course, in this case, the letters, the denominator and the numerator of the multiplier will cancel out, and of course we have 49 times y squared. On the other side, we would have 49 times 36 times 1. And of course, that we could simplify as this. right? We have 1764 for this part of it. We have 49 times y squared, and this here, we have to expand this before we multiply it out. And of course, to expand this, you take the first term and square it, the product of the inside times 2, which will give you minus 14x, and then the last term square will give you plus 49. And that's what has been done right in here. We have x squared minus 14x plus 49. I'm going to multiply that by 36. And when I do that, we see that 36x squared, and this will be 504x, and then we have 49 times 36. Well, we did that calculation before, 49 times 36. So I know that right there, it was 1764, and of course I'm going to put 1764 there. And I put these in red because I wanted to explain when you have the same value on either side of the equal sign, and they have the same sign, they're both plus in front of them, you could cancel them out, because if I take this over to the other side, I will see that it becomes a minus and it cancels out anyway to 0. So that is where we should go with that. The next step of this, 36x squared minus 504x plus 49y squared is equal to 0. And of course, when we are trying to isolate y, we want to solve for y. So we got to take these guys on the other side and divide out that 49 and then take the root of them, right? So when I take this 36 to the other side, it becomes minus. This 504x to the other side, it becomes plus. And then I'm going to divide out the 49. And of course, that's what I have here. We have this, and then you got to take the root of it because it was y squared, right? So you take the root of that, and you have your number. Because these denominators are 49 each, you could write this all as one term, and you could take the root of 49 and take it outside of the radical sign. And that's what I did here. So now I have y solved for in the simplest form that it is, or the prime form, and basically you're done with this problem. And that's all there is. That's all there is to this particular lesson. I hope that you view this and you get some material out of it. And remember to stay safe, because I worry about you guys. Take care. Bye-bye.